And now it is my pleasure to introduce this evening's speakers, Emily Bowe, Assistant Director, and Ian Spangler, Assistant Curator of Digital and Participatory Geography at the Norman B. Leventhal Maps and Education Center at the Boston Public Library. Their talk provides a curator's overview of the latest exhibit from the Leventhal Map and Education Center, which is entitled Processing Place. The exhibit explores the rise of computer cartography and early geographic information systems by way of physical maps created with digital software. The exhibit encourages readers and visitors to consider processing in an historical sense, that is, not only in terms of digital computation, but as one part of a vibrant and ever-changing cartographic process. Through objects dated largely between 1960 and 1990, Processing Place highlights how computer and assisted mapmaking techniques help combine maps with spatial data, perform calculations, and use them to tell geographic stories. By focusing on this period of computerized mapmaking, and this is the point I'd like to emphasize, the exhibit draws attention to the importance of libraries and other map collecting institutions to archive digitally created physical maps from this time period. And now I turn the program over to Emily and Ian. They will address a few of your questions at the conclusion of their presentation. You may type your questions in the chat feature during or after the presentation, and they will address them at that point. Emily and Ian.
Thank you, Ron. It's great to be here tonight, everyone. Give me just a moment to pull our slides up on the screen and let me know if you have any trouble seeing this.
Perfect. No problem, Allie.
Awesome. It sounds like we're great. So, and you'll also have to forgive me for my sniffles. I am in the last stage of a cold that just won't quit. Again, thanks for having us here tonight. My name is Ian Spangler. Emily, do you want to pop your head onto the screen?
Yeah.
I want to make sure everyone can see you.
Yep. I'm Emily Bowe. Alongside Ian, I work at the Leventhal Map and Education Center at the Boston Public Library, and together we were the curators of Processing Place, the show we'll talk about tonight.
So we'll do a little bit of tacking back and forth here to give you all what we think will be a really exciting overview, not only of what's in the show, but both how it came together and where we hope that it goes after it comes down off our walls on March 23rd. Before we dig into that, both of us wanted to take a moment just to circulate some thank yous to Ronald Grimm first for thinking of us to speak here today, as well as the broader Washington Map Society and Joint Map Societies for hosting the program. So thank you all. Processing Place wouldn't have been possible without the support of a really wide variety, a laundry list of individuals, including many map donors and collections donors whom we'll recognize during the course of the talk. Specifically, we'd like to thank Garrett Nelson, the head curator and president at the Leventhal Map Center, who provided significant editorial support and curatorial direction as we worked through the show and its preparation. I want to thank Joelle Riffle, our really brilliant designer, who's responsible for all of the design elements that really bring the maps to life. And we want to thank the entire Leventhal Center staff, past and present, who've helped develop the ideas around this show and animated it for patrons and students through tours and lessons in the Leventhal Center. If you aren't familiar with the Leventhal Center, we're an independent nonprofit. We are at the Boston Public Library, and we're responsible for stewardship and interpretation of the BPL's map collection. We routinely exhibit materials from the collection in our public gallery, which typically consists of two different shows, a permanent exhibition focused on the historical geography of Boston, and then a rotating topical exhibition. Processing Place is the current topical show. It will be up until March 23rd. We offer regular tours in this gallery space, and this one has been a really fun show to give people tours of. Many maps in the show, which Emily and I will often refer to as computer maps, are a sort of uncanny valley of cartography. They don't bear a lot of resemblance to either very old maps or very new maps. And this is partly because their origins are in this hybrid era of cartographic production, where processes of manual handcraft often blended with digital computation in new ways. These maps might be created using line printers or pen plotters or something else entirely. And they were constrained by fonts and colors, but they also used those constraints to push new boundaries into visualization and analysis. On the whole, when you look at the maps in Processing Place and these kinds of maps from this era, they just feel different. And in many ways, they are. Their origins are in a set of tools and logics that were rapidly changing, constantly transforming. And in many cases, those tools didn't persist through today. But many of the underlying concepts, the data structures, the spatial analysis that's present in those cartographic objects do continue to play an important role in our everyday lives. And those are some of the things that we're going to try to unpack for you all in the show. To our modern ears, of course, the term computer map might feel kind of redundant and even anachronistic, right? Almost all maps in the modern era derive in one way or another from computers. But this is a pretty recent development. And in Processing Place, we document one way that we think it's interesting to tell a story about how it happened and why it matters that it happened the way it did. Now, what do I mean exactly when I say computer map? Well, I mean maps like this Computer Atlas of Kenya, created in 1971 by reading spatial data from magnetic tape and a line printer. Maps like this geological map of Edmonton, which is not made by a computer, but which would have been used to create spatial data, digitized in the late 1960s as part of a massive land survey that ultimately creates the term Geographic Information Systems, or GIS. By computer maps, I mean these maps of Nantucket from 1985, which have pastel strokes from a pen plotter that made them that are clearly visible even in these not zoomed in images. And maps like this Census Atlas of Boston, which maps the 1970 census, the first one to use computerized methods to collect census data and put Boston's segregated racial demographics on full display. Altogether, Processing Place breaks down over 50 objects across 9 themes of digital map, of traversing the earliest days of experimental digital computation, all the way up to the institutionalization of digital mapping tools at all levels of state agency. So tonight, Emily and I are not going to talk you through the show theme by theme. If you would like to read through the materials carefully and deeply, we really would love to see you visit us before the show comes down on March 23rd. Or you can check out the digital exhibition, which is available online, and it will remain published on the Leventhal Center website in perpetuity, so long as there's an internet. What we want to do tonight instead is try to give you a look behind Processing Place, where it came from, how it's been, where it's going. So the 3 things that we're going to hit on tonight. First, where it came from. I'll hand it over to Emily to give you a sort of look back at the origins of the show. Then I'll walk us through how the maps in Processing Place can still inform the way that we understand our contemporary geographic lives. And finally, Emily and I will conclude by talking a bit about where we see Processing Place headed in the future, specifically from the perspective of map collections and archives. So on that note, Emily, I will hand it over to you.
As Ian mentioned, one focus of the talk is to discuss the origins of Processing Place as an exhibition, and this section is as much a story about library collections as it is about the exhibition itself. In this slide, you'll see an image that I took of Lauren Chen, our cataloging and reference librarian at the center, with Ian and a man named Rich Grady in his basement a few months ago. We spent the day with Rich combing through file cabinets, drafting table drawers, cardboard boxes, and archival tubes, all to discern what objects would make sense as part of an archival collection within our holdings. I'll talk more about Rich in a moment, but I want to jump into some thoughts that were important as we begin understanding how we curated processing place. Next slide. First, I'll talk a little bit about the origins of our growing set of archival collections related to the history of computer cartography. Then I'll describe the kinds of things that are within those collections and what kind of future researchers might hope to find in them. I'll talk a bit about our strategy that we use to sort of think about building out our collection in recognitions of the existence of other collections. And then finally, I'll note one of the big challenges about growing these physical archival holdings in ways that best describe and document things that are inherently digital. Next slide. Next slide. Ian and I both joined the staff at the Leventhal Center in 2021, but the roots of this exhibition come before we actually arrived, and Ron is part of the story of that, so it's a bit of a circular moment tonight. Here you'll see the kind of early roots of the show. These photos were taken in December of 2021 in the home of a man named David Weaver. He was an elder statesman of sorts within the community of folks who worked on computer cartography in Massachusetts. We might use the term GIS kind of interchangeably with computer cartography. GIS is an acronym for Geospatial Information System, so excuse us if we go back and forth. As I alluded to, David reached out to Ron a few years earlier when his company Applied Geographics Inc., also known as AppGeo, was moving offices in Boston because he wanted to see if the Leventhal Center and the library would be interested in some of their archival corporate records and also some of David's papers. His company had worked extensively with agencies across the state in the 1980s, 90s, and 2000s to create data sets, make maps, and implement modern workflows for GIS while also training plenty of state employees and sort of serving as a trusted resource for many of the agencies adopting these technologies. Members of our team were able to visit his home to begin talking with him about which objects he was interested in donating and which things could begin as the foundation of our nascent archival collecting in this space. Next slide. Much of the actual collecting process behind processing place looked basically like a series of conversations with people like David and a growing web of interlocutors, all while standing over maps. Here you see David with his former colleague, Mike Turner, looking at maps made by Applied Geographics in our collection storage here at the library. Mike and David frequently during these conversations were basically just pulling maps out to tell us stories and show us details that might not be immediately apparent when we were relatively unfamiliar with these maps when we would first take a look. It was especially fun to hear small things that David and Mike remembered and would point out, such as small visual touches like experimental fonts or colors. In one case, there was a map that had a line printer reproduction of a wind head, a la sort of early atlases with wind heads in the corner blowing winds of fate. But also things like the mapmaker's initials placed discreetly in the corner of an otherwise bureaucratic and administrative policy map. Next slide. Especially fun was working with folks like Rich Grady, seen in these photos, to understand the various drafts and changes that went into making a final map. Here on his drafting table, he's showing us dozens of variations on a map that was made to show ski trails in Killington, Vermont. And as we talked to him, he helped us to understand the significance of all these changes. But without his narration, we really wouldn't have been able to make full kind of sense of what we were seeing or see the nuances of each sheet of transparency or each of the pencil edits that were on the piece of paper. Next slide. As we worked to scope what collections held in the BPL on these topics might look like, we worked hand in hand with our colleagues within the BPL Special Collections Department, particularly the archives team, to understand what kind of formats and objects the library was able to steward into the future. For those of you involved in preservation and archives work, And perhaps many of you who have just tried to open a file you worked on 10 years ago that's saved on some kind of external disk, you'll be aware it's much easier to preserve a 400-year-old manuscript map than it is to preserve a digital file made 14 years ago. In that light, much of what we are able to collect are actually the papers of individuals who worked in and around the early advent and adoption of computer cartography. Here you'll see finding aids for both the applied geographics records and the David Judkins Weaver's papers. Each of these findings aids is the result of dozens, if not hundreds of hours of work to research, document, and catalog the items that came in as part of the holdings. We're grateful to our colleague Lauren Chen for all of her hard work to make these as useful to future researchers, which included Ian and me, almost as soon as Lauren hit the publish button on these finding aids. Next slide. During all of the process I described above, one of the things that created a sense of urgency for us was David Weaver had an aggressive form of cancer and had only been given a limited number of months to live. He outlived his diagnosis by a few years, but one of the most bittersweet parts of this whole process was that David passed away last August, less than a month before Processing Place opened. As our chief collaborator in the work, David's knowledge, enthusiasm, and indispensable connections to others in the field shaped much of what we worked to create. And as such, we felt it was only right to dedicate the show to him. I'll circle back to this point later in the talk, but our experience learning from David only honed our sense of urgency for the kinds of archival work needed to preserve resources and document stories from those who lived through and shaped this period of cartographic practice. Next slide. I'll jump ahead. We're going to talk a little bit about the kinds of things that are in some of these archival collections. So I'm going to go through a couple sort of items that feel a little bit special or indicative of other things. Next slide. Some of these aren't in Processing Place, by the way. So not because we didn't like them, but because we have a limited gallery space. So we had to pick. This map is a 1991 map produced to show land change in Mashpee, a town in Massachusetts, between 1971 and 1990. You'll notice there's sort of 5 Mashpees, so to speak, with the maps with the more green background showing the land use at points in time, 1971, 1984, and 1990. In between those maps, there are 2 other maps that show change between them with sort of a white background. It's a creative layout that allows a viewer to quickly understand the locations of the most change in land use during this 19-year period. Next slide. One of my favorite parts, though, is the data table that has quite charmingly been taped to the map, showing calculations that relate to land use changes that have taken place. The inclusion of the data table is a key part of what distinguishes maps made with computers from those that came before. The map itself is in many ways the visual output that represents a computational database. Many of these GIS maps from the 80s and 90s are leveraging the power of calculation that comes from marrying spatial data and computers. Suddenly, math that would have been painstaking and perhaps inaccurate with a human hand is much quicker with a computer and much easier to make updates when there are changes. Next slide. These next few slides I'm going to run through quickly. They're all tools that we collected from various folks. These were David's tools that he had from a more analog period of cartography, one that looked a lot more like drafting, or if there are any architects on the call, you probably recognize some of these architects or engineers, you recognize these as well. Here you've got a range of compasses in a quite nice box. There's a retractoscriber, which allowed a cartographer to create lines on a transparent sheet that sort of had a waxy film on it as part of a layering and drafting process. And then the tool on the bottom right is a curvimeter, which allowed someone to measure curves that were drawn on maps. Next slide. Here, these tools kind of show a range of instruments used in creating lettering on analog maps. And any contemporary cartographer who works on computer mapping will tell you that text placement is still one of the most manual parts of making a map. So in this era, it was no different. The lettering guides above allowed cartographers to create consistent lettering, and accessories like the tool on the bottom right allowed them to adjust the height, slant, and spacing of the letters to achieve any range of combinations for text. These tools were all sort of superseded in computer programs, but for a period of time, there's kind of an overlap between these manual tools and computational process. Next slide. This was actually one of the things we knew was going to be the show earliest. This is a digitizing puck. Many of you If anyone used this, go ahead and put a comment in the chat because I would love to know if there are folks here who ever had to use one of these. This was David's. It came to us with the cord cut, so it's we only know that it worked at one point in time. But these digitizing pucks, you would hold them like much like a computer mouse, and an operator would create sort of points. They're digitizing and tracing something that they want to become a computerized data layer. So they would trace the puck across some kind of paper map, and basically using combinations of button inputs, and then wherever the pucks, the crosshairs of the puck would sit, you could basically create points that would get logged to the computer. Software would then interpret and display these points, and could sort of interpolate them into individual points, lines, polygons, other shapes in some kind of mapping software. Photograph to the right shows sort of a setup for a digitizing table that someone might have used when tracing an existing map or an aerial image. Next slide. Plenty of things in the collections are representative of kind of in-process cartographic production, such as these two images. There's nothing super special about them, but they do give you a little bit of a window into how a company that made maps for state agencies might have done batch production of things. These are excerpts of larger sheets that contained maps for dozens of coastal towns across Massachusetts as part of a project that looked at coastal zone management across the state. The image on the right is part of a review document that was made by a supervisor who reviewed the production of the maps and wanted to indicate to the production team where the title block, map key, and scale bar would go. The first time we saw this, Ian and I both sort of had this moment of remembering every single one of our GIS professors from college harp on the fact that there's very important placement for title blocks, key, and scale bars. So nothing much has changed there. Next slide. This binder is kind of a special, unique object. It's a 1990 training manual from Massachusetts state agency, MassGIS, that helped train dozens of employees in how to use new statewide mapping software. This particular one was from Mike Turner, who I mentioned earlier, hence his initials on the top right. Today, it would be near impossible to get a working version of the 1990 software ArcInfo referenced in this binder on any kind of computer. But the training exercises and the printouts provide a window into both the ways training individuals worked at that time as sort of a window into personnel and training processes, but also the way the logic of the softwares was sort of built out, and the kinds of commands you needed to know, the types of things you'd have to reference. The way these binders were heavily marked up indicates that they were sort of a staple of your desk. You had them close at hand whenever you were using these tools. Next slide. What you're seeing here is the front page of a 1990 document called the Executive Office of Environmental Affairs MassGIS Geographic Information System Transition Document. It was a document created by the company Applied Geographics for MassGIS, the statewide office responsible for the state's geospatial data. And the document, the thing that this image doesn't convey, it's very large. Imagine the size of an architectural blueprint. The copy that we have was probably something that existed in the middle of an office somewhere as a reference document for lots of folks. This cover shows the state with all the townships and the town boundaries, but also various administrative divisions marked. Next page. One of the early pages in the document contains a short series of text that's very helpful in explaining the background, and I'll just highlight in the next two slides some of that text. Next slide. One of the sections on interagency cooperation says 130-member organization representing many state agencies, authorities, private companies, and regional and local governments that are users of these systems were represented in the production of this document. And this felt noteworthy in an era where the administrative state is under heavy scrutiny, and records of this kind of widespread agency and public collaboration feel noteworthy. Next slide. My other favorite bit is the following excerpt, which says, a picture is worth 1,000 words, and MassGIS has given EOEA, among other things, the ability to view complex environmental issues in the familiar format of maps, which describe resources, which resources are at stake, and which alternatives may be available. So the rest of the document is examples of maps that were made using this software to be able to sort of visualize these various environmental and stakeholder challenges. Next slide. One of the things we thought a lot about was building on existing collections. So next slide. The Library of Congress has an amazing kind of growing collection in the history of GIS. This was one of our starting points, especially the blog posts, the series of blog posts that John Hessler did a number of years ago, exploring some of these holdings and also giving us a really good jumping off point. Next slide. The LOC's collection contains papers from a number of analytic geographers and early GIS innovators, such as Nicholas Chrisman, Joel Morrison, Waldo Tobler, and Roger Tomlinson. And it helped us identify the role that we might be able to play in filling other kinds of gaps in the archival record for this period. Next slide. Ian got to visit LOC during the curatorial process. So this is him very excited in front of the giant globe, but was able to see some of these papers. One is Waldo Tobler's visualization of Michigan's population by county, and then the other is papers from Virginia Norwood with designs for what would eventually be adopted into the Landsat satellite imagery program. Next slide. This last bit is on the challenges of documenting digital things with physical objects. Next slide. This slide shows two images that represent the same technology, CIMAP. CIMAP was a software program created at the Harvard Laboratory for Computer Graphics and Spatial Analysis. It allowed a user to print a representation of spatial data on a line printer using a series of overprinted characters to create different symbologies. It's one of the more significant software turns in the history of computer cartography, and it became the foundation for many things that came after it. Preserving CIMAP is a challenging thing to do in its original medium, as what remains is a copy of CIMAP on magnetic tape, shown on the left, which requires all the necessary hardware to not only exist, but also function into the future. Within libraries and archives, we tend to think about these concepts of preservation and access on the scale of decades and centuries. So preserving natively digital software and what's known as born digital maps is complicated. This image on the right is from a user manual, which is part of archival collections at Harvard for CIMAP. And this is something that's much easier for us to be able to preserve, something that's on paper, as opposed to sort of the original software itself. So this is kind of one of the challenges of this period of time. And next slide. This issue of collecting born digital material, including maps and software, is one that pretty much every major map library collection is contending with. This is a recent article from a 2023 issue of the journal Imago Mundi, which is focused on a whole discussion of this topic. There's a number of other authors who are part of it, but this is sort of not just us that are trying to reckon with this. This is a industry-wide kind of thing. So I'll turn it back over to Ian for this next section.
Great, thanks, Emily. So we have a strong foundation of some of the organizing concepts for where processing place comes from. So let's jump back into the show itself, right? How can we use some of the maps in this exhibition to understand our contemporary geographic lives? And what can we learn from these so-called computer maps? I'm going to go through 5 what I think are sort of concrete lessons that we can take away. And the first one, I want to start where any self-respecting GIS class would start, which is with layers. And I want to highlight how cartographic layers in these maps are also social layers. So let me tell you what I mean by that. Layers, of course, are a heuristic for making sense of the world. We separate observations, features on the surface of the Earth into different layers to class them into categories, right? It's a way of cartographically sorting things out. This is a map that predates the concept of GIS by many years, 1912, a guy named Warren Manning. And And it's originally identified as a sort of overlay technique in an interesting 1972 essay about the history of hand-drawn overlays. Here in the red shaded areas, we have forested lands in Billerica, Massachusetts in 1912, and the dark gray are forested lands in 1853. The map starts to gesture towards the ways that you can take different data layers and perform overlay calculations between them, right? As a sort of way of doing spatial math. The authors note in this article that this is the earliest evidence of the use of data overlays as an analysis technique, right? And that's really important for what will ultimately become GIS, right? By turning observations about the world into data layers, we can go from representation to analysis. And this map of tributaries to a large reservoir in Massachusetts towns is a great example of that. We have these bright red areas of urban space that explode out of this map, and the round sort of turquoise polygons that meander through it represent 200 and 400 foot buffer zones around the tributaries. They want to be protected, right? Of course, the point of the map here is not actually the map. It's really the numbers that are listed in the table to the right, which I've screenshotted as well. They summarize the percent of land area that needs to be legally protected in order to preserve those buffer zones. More to the point here, the buffer zones aren't actually something that exists, right? These don't exist out in the world. They're a sort of social representation created in order to turn an idea, the idea that this water should be protected, into a policy. But simply, the cartographic layers here are social layers. This is another great example of layering, albeit a more complex one than the forest map that we just saw from 1912. The pastel greens and blues of this map contain all sorts of distinctive features. We find lakes, streams, wetlands, parks, many different kinds of roads just in this small crop. This was a map produced by the Defense Mapping Agency in 1976, not for analysis, not for visualization, but as they write in the margins, as part of work performed to study the automation of cartography. A separate description attached to the map provides details about the map's production methods, the different materials needed to produce them, and some of those include things like Goodyear and the Staran array processor, right? Old technologies that might feel very foreign or far away from our contemporary GIS tools. And that's because back in 1976, GIS was not some centralized software, but it was an experimental and pretty far-flung set of independently developed algorithms that were shared and maybe even stolen across and between different government agencies, university labs, and private firms. The map is featured in this interesting history of the Defense Mapping Agency. A much simplified version is included in the pages, which highlights that it was just used to demonstrate the capabilities of raster processing in the 70s. Something that's really interesting about that manual is the preface. They highlight the importance of computer technologies to the U.S. Army, allowing to meet its needs for topography, terrain, and so on. To put that another way, they sum it up much more easily later on. If a target can be seen, it can be destroyed, right? Which brings me to my second point, that military power is tied to lots of seemingly neutral things like technological change or resource management. And these maps articulate that in many cases. Resource management is, of course, an important part of GIS and a key part of the origin story. The map here is a geological map of Edmonton, part of the Canada Land Inventory in the 1960s. This map would have been digitized to create spatial data. Much like the space portrait of the United States, this was a series of satellite images that were stitched together in 1976, showing dense vegetation in bright red. The verso of the map is boldly titled Monitoring America's Resources. And they give a lot of examples about how satellite imagery supports this process. The new Landsat satellites had just launched in the 70s, from forest management to urban development and so on. Washington, D.C. gets a little shout out in this map, so I had to pull that out for anyone who's calling in from Washington tonight. The authors of this map write that Landsat provides a chance to systematically study the Earth from a great distance. Of course, in 1976, that systematic study extended well beyond agriculture, well beyond mineral exploration. It included the military machinations of the Cold War and geopolitical anxieties between two superpowers. And nobody summarized that better, I think, than Lyndon Johnson, who said in 1967, we've spent 35 or 40 billion dollars on the space program, and if nothing else had come out of it except the knowledge that we gained from space photography, it would be worth 10 times what the whole program has cost, because tonight we know how many missiles the enemy has. Or, put more simply, if a target can be seen, it can be destroyed. In an excellent new book called The Map in the Machine, Luis Alvarez Leon observes that only 30 years ago, a handful of countries in the world had full-throated satellite capability. Today, that number is over 100. And that increase is not just a response to a need for better resource management, right? It's a desire to better manage national security, to see targets more efficiently. If our world is vastly more connected than it was before, it's because technology like this makes new spaces and times. This is a map of Bangladesh created using the SIMAP software that Emily spoke about. Zooming in, we see some familiar characters like zeros and plus signs, which were printed using a line printer. The legend captures this kind of interesting variable, percent of families by damaged housing status in each district of Bangladesh. In 1972, Bangladesh was reeling from an awful convergence of disasters, including a civil war and a campaign of ethnic cleansing by the Pakistan army, which both culminated in Bangladesh's independence as a new nation. So this map is capturing a really pivotal time in their history. Now, when this atlas was originally published in 1972, the authors simply used data from existing censuses. But in a republish of the atlas in July later that year, a new survey had been undertaken by the United Nations to assess the damage from those atrocities. And they were able to reproduce the atlas entirely, adding dozens of new maps. In this case, computerized methods weren't just important for making the maps. It's really not possible to do it without them, right? To take this turnaround time of just a couple months, cartographers could go from receiving data to producing a fully fledged atlas. Put simply, the computer sped things up, and it changed the time frames through which we could understand space. And the legacy of that impulse to represent humanitarian disasters is still with us, right? And things like humanitarian OpenStreetMap, and things like satellite images that allow us to look at damage in Gaza, in Ukraine, and even natural disasters like the Palisades and Eaton fires, which are ongoing. Of course, not all maps are fire and brimstone. Some are playful, some are simply designed to sell you something, right? And that kind of mapvertising brings me to my fourth point, that advertising in maps is not new, right? But the way it happens is pretty new with digital technologies. This is an old map from our collections advertising new homes in Dedham, in Massachusetts, similar to this one in Orient Heights in Boston, right? You would see these sorts of maps all over the place at the turn of the 20th century. So advertising in maps is really a very old thing. But in the 1960s, at the turn of the 1970s, we started to see a new kind of advertising. This is a public environmental information system created by the Boston Redevelopment Agency, sort of flavored as this public good. They were large kiosks topped with enormous balloons that people could press different buttons and ask questions about the city, right? Where am I? What used to be here 100 years ago? Tell me about the history of Boston. And a voice might speak back to them, or they might get a printed out bit of information. The most geographical of this was the Directomat, which gave people directions to nearby attractions. The kiosks show us two things that I want to highlight. Right? First, that technology has for a long time been viewed through solutionist lenses. This snippet that I've got on the top of this slide explains one of the benefits might be as the district centers develop, you could have possibilities for communication between different populations. For example, a quote, Black movie shown to the Irish in South Boston. Right? The idea here being that technology is a very efficient way of solving persistent social issues like racial, economic difference. A second point below it is that these centers, the authors plead that the centers remain public institutions so that they're not just turned into selling machines, as they say. Of course, this is exactly what happened 2 decades later with a walking distance locator kiosk, which was a subscription-based kiosk installed in Boston that different bookstores, design shops, restaurants would pay to be listed in. Folks could come up to it, press a button, and get a little map printed out, walking to their nearest attractions. Of course, now we have things like Google Maps, which advertise to you not based on subscription models, but actually based on your information profile as a user, right? So there's a whole genealogy to the way that those things develop. The last thing I want to highlight is the ways that computer mapping is a deeply human process, right? It's something that's flawed, it's path dependent, and it's contingent on the people who make the maps at the end of the day, right? And I want to highlight this shade set, which is basically like a color palette in our current exhibition. This would have been used by people like David Weaver and Rich Grady, the folks who we've mentioned already tonight, to make decisions about producing their maps, right? It's a reminder that color was not an accident. People took a lot of care and time in choosing their colors, and that happened very differently at the sort of early days of GIS than it does today. If you zoom in, you can see some of the workmanship on this map, which is really represented in pencil strokes connecting one color to another and circling colors that they might want to use in a particular project. A really deep zoom gives us a sort of, to me at least, a nostalgic sort of typography and design in these swatches. The thing I want to draw your attention to most is this little circle with Aaron's room inside it. When David Weaver's daughter, Erin, visited the center, she leaned over the glass case in which this map, this object is displayed and said, "Did you notice that 314 is listed as Aaron's room?" And I said, "No, I didn't." And she said, "Well, that was the color of my room growing up, this pink, this light pink." David had also used this color swatch sheet to choose their porch color, which was just white. But these little notes are a really useful reminder of the humanity behind not just this map, but all maps, right? That human decision-making is implicit and actually necessary in even the most seemingly impersonal computer maps. I know we're right at 7:50 right now, so Emily and I have a good bit more that we can tell you guys about the show, but it might be a good time to just pause and open up for questions if we're stopping at 8. Ron, could you give us a little temp check on where we are?
Yeah, let's open it for some questions. But first of
Great.
all, I'd just like to thank you for this presentation and what I consider you took an archive that we were thinking about just before I left the Boston Public Library. And you've taken it and you've interpreted it and have given it, I think, quite a bit of meaning. And I have lots of thoughts as I look at this, but part of what I see is, wow, wouldn't it be great if we had this kind of documentation for some of the maps that were produced in the 1500s and the 1600s. So yes, I think you have taken one archive, which probably is not a comprehensive archive, but you have basically shown how it has documented the process. And for that, I congratulate you. Let's see, there were a number of comments. Let's see if there are any questions. And I thank you for recognizing David Weaver. He was an active member of the Boston Map Society, and that was part of our connection with him.
Yeah, it really, we can't emphasize enough. The dedication truly doesn't do justice how closely David was involved in the creation of this show, both through, as Emily said, his advice and stories, as well as the objects themselves. So yeah, it was the easiest decision that we had in the entire show to make sure that he was recognized at every step of the way.
Okay, it looks like there are a number of comments, but not really questions. And hopefully we could reproduce those comments for you. I don't,
Looks like there were lots of folks that responded to my digitizing puck prompt. So I'm
yes,
excited about that.
yes.
Very fun to see those stories.
Okay. I don't know. Can you do another 5 or so minutes, 10 minutes?
Yeah, we definitely can. And I think you'll probably enjoy this last chunk of slides that we have. So let's jump back here. We want to look ahead to the future. So Emily, let's see if we can sort of jump through what remains in this slide deck. The first point that we want to highlight, looking ahead to the future of computer cartography archives, really this question around like, where do we go from here, right? Processing place was a great chance for us to flex interpretive muscles with objects in the collections. But we're at a really pivotal moment, Emily and I both think, where we need to be intentional and critical about how we continue preserving these objects. So the first thing that occurs is the need for a finding aid of finding aids. The objects in the show are scattered all over the place, right? The stuff just that I talked about. Here are 8 objects from 8 different sources and origins that span the Library of Congress, that go all the way up to Canada, the University of Alberta libraries. Many of the maps that we displayed were interlibrary loaned from other places. So there's this sort of central question of anyone who wants to work with these materials and gain a better understanding of the story almost needs a sort of conceptual map that will show them where the maps are, right? A finding aid of finding aid. So that's a really important first step.
Another thing we sort of took note of is the need for oral histories as a way to fill in some of the gaps. We were really struck by the Geographer on Film series that the LOC has. Next slide. And noticed that many of the maps in our gallery, when we've brought people in or had people that were part of the production come talk about them, we learned so much more than we can just analyzing them visually. So this map's one that was produced as part of for the Massachusetts Executive Office of Environmental Affairs, and it's showing areas of critical environmental concern. But the real thing that I want to point out, next slide, when we toured MassGIS through their current staff, the former executive director, Christian Jacks, came in, and the thing he wanted us to sort of know above all else is that these maps served as convening functions, getting all of these different parties, right? The Department of Environmental Management, the Metropolitan District Commission, the Department of Fish and Wildlife, all the rest, around a table together, looking at a common vision or a common display of an issue. And that was honestly, in his mind, one of the first steps towards dialogue and towards solving many of these different policy challenges that they were facing. Next slide. Other things are just more, you're not going to get the fun details unless you talk to someone about it. These were things that look on their face like dot matrix printed visuals of some elevation data. In one of our later conversations with David, he told us that he actually grabbed them off of the printer when he was a graduate student in Waldo Tobler's lab. So these were made as part of one of Waldo Tobler's experiments that he was running or trying to visualize, which made them all the more interesting to us. They sort of stopped just being just dot matrix printing. They felt like a draft in progress that is pretty rare to see. Next slide.
Yeah. So a third point here is that when we think about computer cartography, collections and archives, well, map collections in general are about maps, right? Map cartographic objects, but it's important when it comes to computers to reckon with mapping primarily as a practice, like as a thing that you do, not just ending with the objects themselves. One thing that highlights that is the ETAC navigator in our show. This is actually loaned to us from the personal collection of one of the folks who founded this navigation tool. If anyone used this in the 80s, we would really love to hear from you, because this is one, a sort of deep cut from the first vehicular navigation experience. You would install this in your car and load map data from a cassette tape, and some other you can read more on the website about how it actually worked, but this would sort of display map data for you. This is a mapping process, and it's a process that's truly like still guides the way that we interpret maps navigationally today, all the way down to the way that they represented information. The sort of cartographic convention of an arrow in the center of a screen that stays in the same spot while the map underneath it moves. That is so familiar to us today that you might not even notice that it's a convention. ETAC was the first company that did it, right? So it has its own material history as well. I think I'll skim over these ones and just send it back to you, Emily, to close us out.
Yeah, so this last point I wanted to make was just basically the need for better representation in archival collecting within GIS history. So this still is from a documentary that was called Data for Decision, that was made by the Canada Film Board as a promotional film describing Canada GIS, which was largely considered sort of the first major sort of governmental GIS. And it's showing basically all of the, quote, computers, right, the human computers that were involved in taking data and turning it into things that computers could use. Many of these women were using punch cards. You'll see the accuracy sign very prominently in the right-hand side of the image, and the in, checking, and out boxes in that bottom right hand of the image. Next slide. One of the objects in the show, which may look just super simple, is a coding form pad, a Fortran coding pad that was given to us by Rich Grady. He talked about using them all the time. They were basically scratch sheets where as you were trying to figure out what you wanted to do, you're trying to draft code, and you draft it on these pads. Each horizontal row would translate to one Fortran card. And so you could kind of draft many, many lines of code here. And then typically what would happen is these would get ripped off and given to secretaries to input in as Fortran cards. Next slide. So the sort of gendered nature of the labor involved in both the kind of coding process and typically things that may have been more clerical. Plenty of people in the chat were using these digitizing pucks. We just happened to find lots of images, promotional images of women using digitizing pucks. Next image. And I think one of the things that has been really present in the last couple decades is sort of these stories that challenge the kind of great singular person narratives that have shaped technological histories. There's a great book called Broadband by journalist Claire Evans that's based on a series of oral histories about the origins of the internet in California and the origins of computing, and these sort of really non-traditional stories that you don't really know. Recent kind of stories, Margaret Hamilton's Apollo code that sort of was brought to light after MIT found a lot of the documentation, and Katherine Johnson, her story being made into motion pictures about her role as a computer at NASA. These are just sort of smaller vignettes, but I think a need for something like this within computer cartography, and the fact that it wasn't just one person who invented a software or one person who made a change. There were all these different people involved along the way, implementing it, shaping it, changing it, adopting it. And we need something that can sort of cohere all those narratives together. Next slide.
Just a summary of those key beats. I think that's probably where we'll leave it tonight. I know we're right at time, so if we have any sort of final thing to say, it's that looking ahead to what often feels like an uncertain future can often be clarified by looking backwards at maps like these, which still bear a lot of continuity. And I think we can learn quite a bit about our modern digital tools from becoming more familiar with these slightly older ones. Also, open call if you guys have anyone on this call as maps that they think would be a good fit for the Leventhal Center's collections. Emily and I are all ears. We're sort of hoping to use Processing Place as a chance to grow our collections in the history of computer cartography. And I'll also note in the chat here, just in case anybody is interested in supporting this kind of work moving forward, we are collecting donations on an ongoing basis to support a fund established at the Leventhal Center in honor of David Weaver. So if you are interested in contributing to the GIS Research Fund, we would really welcome that. Emily, is there anything that you want to add to cap us off tonight?
Yeah, I just want to say thank you to everyone who's adding great stories in the chat. I'm going to be downloading this Zoom chat and probably Googling a lot of names later. So I'm really grateful.
Okay. Again, thank you for this presentation. I realize probably a lot of our members here are much more interested in the older cartography, the pre-computer era. But if you found this interesting, I would suggest that you also read the 4 short pieces that are in the Imago Mundi article that Emily cited. I think that was volume 75, part 1. And it discusses some of the major issues in conserving and preserving the digital cartography, not only of the 1980s and 1990s, but current concerns as well. So.
I just wanted to jump in and say I love the way you raised those ads. I'm Karen Pinto. I was one of the people who put down that I use the digitizing puck, and I actually forgot about it until you asked. And you know what's really interesting is I don't think I have a copy of the map we created. You know, you got me thinking about, I wonder how I could get that. And I forget what we created it on, because you know, it was like, you know, the computers were, I mean, I started on a 124K. I mean, I've been doing this for a while. So, but you know, the ad you had about how women, they were advertising women as, you know, using these pucks. That's kind of neat, actually. I don't know. But anyway. Yeah. So the reuniting of North America. So anyway, yeah, just wanted to say that. Thank you. Thanks for
Karen.
the talk.
Okay, I'd say we're about 10 minutes after the hour. It's probably time to close, but I think if you have things you want to communicate with Emily and Ian, can find their emails on the Leventhal Map Center site. And Emily and Ian, thanks again. And there will be a few little gifts as well as for you as speaker gifts, but some other things that I've been collecting that I've been meaning to send for the library.
Perfect. Thanks, Ron.
Yeah, we look forward to that, Ron. Yeah, thank you all for tuning in tonight, and hope we can find a way to stay in touch.
Take care.
Okay. Thank you, everybody. Have a good evening.
Take care. Yeah, take care.
No touch.